Welcome to Seismic Data Processing course. So in today's lecture we'll talk about the characteristics of waves. What is the amplitude? The amplitude is the maximum distance, is the maximum displacement of a particles from its rest position as the wave passes. So if we imagine this one is the rest position, in the normal condition we have rock particles, it is in the rest condition, and then when the energy is released, these particles will move up, down if the wave type was shear wave, second wave, and it will move horizontally if the wave type was primary wave. So the wave it will be horizontally, but the particle move it will be up and down or horizontally, depend on the type of wave. The height from the central line to the crust. So the height from central line to the crust, this is the amplitude. A large amplitude, if we have a large amplitude, we have a large energy release. We have another property, it's called wavelength. The wavelength in the short is the how long is the distance. So how long is the distance per one cycle. So from the rest point to the crust, and then to the middle of the rest point, into the trough, and then back to the center, this is one cycle. So how long the distance it will take to complete one cycle. So the distance per one cycle is called the lambda, and the lambda is the wavelength. So the distance between 2 points that are in the same phase, for example from crust to crust or from trough to trough, it shows how long each wave cycle is in a space. So also we have the period. The period is the time taken for one full cycle to pass a fixed point. So for a fixed point we have the seismometer on the surface, and this one it will record how much time it taken for one full cycle to pass. One full cycle to pass, how much time it taken. These are the three most important characteristics of waves. So the amplitude, how much distance, how much displacement it take, the maximum displacement from the rest point into the crust. But the just illustration for show you the displacement, but in real life maybe we have vertical displacement or horizontal displacement, depend on the wave type. So also we have the frequency. The frequency is how much cycle per second. So how much the number of cycles per second, this is the frequency. If we have low wavelength, that means the distance is very long. With low wavelength, that means we have low frequency, low energy. And if we have short wavelength, the lambda between crust to crust or between trough to trough is very low. That means we have high frequency and high energy. And also the frequency is divided by 1, dividing by the time. So if the time in here is very high, that means the frequency it will be very low. And this is low frequency, we have the wavelength, it will be very long. But if we have a short time, the frequency will be very high, and then we have high frequency. Okay, so number of cycles per second. We have 1 second. How much number of cycle per 1 second? If we have 1 cycle per second, so we have 1 hertz. Also 1 cycle per second is equal to 1 hertz. So 1 hertz is 1 cycle per second. And the frequency is measured by hertz. So if we in 1 second, how many cycle passes? If it's 1, then 1 divided by 1, we have 1 hertz. If 2 cycles passes per 1 second, so 2 divided by 1, then we have 2 hertz. So 2 hertz, 2 cycles passes per 1 second. This is the frequency. So we have this is amplitude and frequency. These from the rest point into the crust, and then back to the middle of the center point, and then the trough, and then we back to the center point. This is one cycle, and then up, down, the center. This is second cycle. So we have in here 2 cycle per 1 second. So the number of cycles, 2 cycles per second. And what is the amplitude? The amplitude is the vertical displacement in this illustration. So from the rest point until the maximum highest point that the wave is reached. So it's from 0 to 0.5. So the maximum will be 0.5. So 0.5 is the amplitude. And what about the frequency? So frequency, we said the number of cycles per second. We have 1 and 2. So 2 cycles dividing by 1 second is still, you have 2 hertz. So 2 hertz is the frequency, and number of cycle is 2 per cycle, 2 cycle. Okay, so from 0.1 into the time 1, this is the cycle. This is 1 second. In 1 second we have 1, 2 cycle per 1 second. This is the frequency. So calculation of wavelength, in here we don't consider the time, we consider how much the distance that to complete one cycle. So this cycle is from the rest point into the trough, and then back to the crust, and then back to the center. So the wavelength is equal to 0.8 kilometer. We also have the seismic wave velocity. The seismic velocity is the speed at which the seismic wave moves through a material. So how much speed this seismic wave can pass through a material. So it's also depend on the rock property. So it depend on the material property. Meaning it's depend on only on the rock, not on the size or strength of the wave. So no matter what the size or strength of the wave, it will depend on the rock properties, like the elastic modulus of the rock. When the rock is deformed, it will change its properties, the density and porosity. So it depends on the rock properties and the density of the rock. Okay, the velocity will depend on the two factors, the elastic parameters and modulus of the rock. They describe how the rock deform under stress, and also the density of the rock. It's not depend on the how much wave or the energy released from the wave. This relationships came from the Newton's second law, the force equal to m multiplied by the acceleration, and Hooke's law connects stress and strain. Okay, so together these laws describe how stress and strain propagate through a solid, leading to the law velocity equations. And the equation to calculate the velocity of waves, we have, the velocity is the distance by time, but in seismic we have the frequency and wavelength. So velocity equal to frequency multiplied by lambda, the wavelength. So we have frequency, cycle per second, hertz, and we have the wavelength, the distance per cycle. So wave velocity is how many cycles occur per second, multiplying by how long each cycle is, we get the velocity. So this is the illustration how we change from time distance. From the cycle we have the frequency, it is cycle per time divided by time, and the lambda is the distance per cycle. So if we eliminate cycle by cycle, we have the velocity equal to distance multiplied by time, and this is the velocity. So to calculate the velocity, you have the wavelength is 0.8, and you have the and we have the frequency and the frequency is 2 Hertz. So 2 multiplied by 0.8, we have 1.8 kilometer per second. So this is all you need to know about the characteristic of wave. So thank you for watching and see you in the next video.